गुड इवनिंग क्लास। आज का हमारा टॉपिक है पैराबोला। सो टुडे वी आर गोइंग टू कवर पैराबोला. Some basic things about parabola. First of all, if we will see the general equation of parabola, either y square equals to 4ax. So this is the parabola, or secondly x square equals to 4ay. Then you will have this parabola if a is positive. In case a is negative, then the parabola will be this one, and in case the a is negative, then parabola will be this one. Okay, uh, let's go to our questions. First question is the equation of common tangent to the parabola and the circle. So here we are having a parabola and a circle, and we need to find the equation of the common tangent, that is a equation of a line which is tangent to both parabola as well as circle. So for parabola, if you are having the equation y square equals to 4ax, then equation of tangent is given by y equals to mx plus a by m. Now see, here m is the slope. If you will compare this equation and this equation, then you will get 4a equals to 2, so a will be equals to 1 by 2. So our equation of tangent will be y equals to mx plus 1 upon 2m. Now this is equation of tangent to parabola. We are also given that the equation of common tangent, since this tangent is also tangent to the circle, so we are having the concept that if we are having this graph and this is a tangent, then it will only touch at one point. So what you have to do is, the basic rule is form quadratic in x or y and put discriminant equal to 0. Why we are doing this is because if we are having a quadratic in x or y, means this is the equation of line, this is the equation of curve. What you have to do, substitute the value of y from this equation of tangent to the equation of curve, and in that solve that equation. You will get a quadratic in x. Now since this is a quadratic equation, it can have maximum of two real roots which can be distinct. But here two roots will signify, two distinct values will signify the point of intersection. This will be x1 x2, and since it is tangent, so it should have the same value of x1 and x2. So we can say this quadratic equation formed in x will have real and equal roots. So the condition for the real and equal roots is discriminant is equals to 0. Now we are having this equation, we are substituting the y value of y in the equation of circle. So we will get x square plus mx plus 1 upon 2m whole square plus 4x equals to 0. On solving, you will get a quadratic equation in x, that is x square 1 plus m square plus 5x plus 1 upon 4m square. So from the general quadratic equation ax square plus bx plus c equals to 0, we are having a equals to 1 plus m square, b equals to 5, c equals to 1 upon 4m square. And since discriminant equals to 0, so b square is equals to 4ac. So b square equals to 4ac. On substituting that, we will get 25 equals to 4 a1 plus m square and c1 upon 4m square. So this will cancel out and we will get 25m square equals to 1 plus m square. So 24m square equals to 1. So m will be 1 upon root 24 in plus and minus. So first of all, we will take m equals to plus 1 by root 24. Then you will get 1 upon 2 root 6. Then we will get m equals to minus 1 upon root 24. And on substituting, you will get value minus 1 upon 2 root 6. So basically substituting this value of m in our equation which we have got, the equation of tangent we were having was y equals to mx plus 1 upon 2m. From this, substituting two different values of m, we will get two different equations of tangent, and the answer is this. This is equation of tangent 1, this is equation of tangent 2. Now let's see this question one more time. In this question it was given we need to find the equation of common tangent to the parabola y square equals to 2x and the circle x square plus y square plus 4x equals to 0. The basic concept we are using here are, first of all, the very first concept in this question is we need the equation of tangent. So for the curve y square equals to 4ax, equation of tangent is y equals to mx plus a by m. Secondly, we have substituted the value of y in the equation of circle and we have got x square plus mx plus a by m whole square plus 4x equals to 0. Now this will give us a quadratic in x, and putting the discriminant of that quadratic equal to 0, we will get two values of m. Now, from these two values of m, we will substitute it in the equation of tangent. Let's say it is equation 1, and we will get two equations of the tangent at a point. Moving to the next question. Our next question is the slope of tangent to the parabola. We need to find the slope of tangent to the parabola y square equals to 9x, which passes through the point 4 comma 10. Obviously this point is not lying on the parabola. So what we have here is, on comparing with y square equals to 4ax, we are having 4a equals to 9, so a equals to 9 by 4. Now equation of tangent is given by y equals to mx plus a by m. Now the value of a is 9 by 4m, so y equals to mx plus 9 upon 4m. It is also given that this tangent passes through point 4 comma 10, so point 4 comma 10 will satisfy the equation of tangent, so we will get 10 equals to 4m plus 9 upon 4m. Solving it, you will get 40m equals to 16m square plus 9. So we will have a quadratic equation in m, that is 16m square minus 40m plus 9 equals to 0. You can solve this quadratic equation and you will get the values of m. Now see, we are having this quadratic equation, we can solve it by Sridharacharya formula and we will get the value of m as 9 by 4 or 1 by 4. Okay, so the right answers are 9 by 4, 1 by 4, that is A and B. Moving to the next question. Our next question is the tangent to the parabola y square equals to 4ax is inclined at an angle pi by 3 with an axis of the parabola. find the point of contact. So you can see if we are having some parabola like this, and it is given that the tangent is inclined at an angle of pi by 3. So that angle pi by 3 can be either like this or it can be this. Okay, we are just given the angle. It is not given that it is in the clockwise direction or anti-clockwise direction. So what we are going to do is we are having two possibilities. So if the angle is pi by 3 and slope, then it will be 10 pi by 3, that will be root 3. Otherwise the slope will be 10 minus pi by 3 and it will be minus root 3. So we are having the two values of slope. Now equation of tangent at a point x1 y1 for any curve is given by t equals to 0. To convert any equation from s equals to 0 to t equals to 0, what we have to do? We have to do the following conversions. X square replaced by xx1, y square replaced by yy1, x replaced by x plus x1 by 2, and y replace it by y plus y1 by 2. Now, we are having a parabola. If we replace it by some point x1, y1, then we will be having two variables. Better we can change it in the parametric form. So the parameters for this parabola are 80 square and 280. So from y square equals to 4ax, equation of tangent will be, our x1 will be 80 square and y1 will be 280. So it will be y1, that is 280, is equals to 4a, in place of x plus x1 by 2. So this we will cancel out and it will be cancel out. So we will get the equation of tangent as yt equals to x plus 80 square. So we are having the equation of tangent yt equals to x plus 80 square. Writing in the form of y equals to mx plus c, and comparing, we can see y equals to 1 by tx plus 80. So our slope will be 1 by t. Now we are having two values of slope. M was equals to plus root 3 or m was equals to minus root 3. So t will be equals to either 1 by root 3 or t will be equals to minus 1 by root 3. Our point of contact were 80 square comma 280. So putting this value, first 1 by root 3 and then t equals to minus 1 by root 3, we'll get 2 points. A by 3, 2a by root 3, that is a into 1 by 3 comma 2a into 1 by root 3, or a into minus 1 by root 3 square we will do, then it will be 1 by 3 comma minus 2a by root 3. So our correct options are A and D. Now, moving to our next question. It is given that a tangent is drawn at a point x1, y1 other than the vertex on the parabola y square equals to 4ax. If tangents are drawn from any vertex point on this tangent to the circle x square plus y square equals to a square, such that all the chords of contact pass through a fixed point x2, y2, then we need to find the relations. How we are going to do it? We are having this point x1 y1. So writing it in the parametric form, it will be 80 square comma 280. And we are drawing a tangent, so equation of tangent will be y1 is equals to x plus x1 by 2. So our equation of tangent will be yt equals to x plus 80 square. Now the tangents are drawn from any vertex point of this tangent to the circle. Okay, so what we are having, we need to find the equation of chord of contact on the circle from the tangent. We are having some point, this, from this point we have drawn a tangent, and from any point on the tangent we have drawn a chord of contact. So let's say this point, we are having the equation yt equals to x plus 80 square. So let's say x equals to h, then on substituting we will get y equals to h plus 80 square by t. So from this point h comma h plus 80 square by t, we have drawn a chord of contact. From any external point, the equation of chord of contact is t equals to 0. It is equation of chord of contact from any external point. So in this, we are having equation of circle x square plus y square equals to a square. So x1 is this h plus y1 is h plus 80 square by t is equals to a square. Now, on solving this equation and rewriting it and arranging it, we will get yt minus a square plus h x plus y by t equals to 0. See, h is any point, h can be any real number. So we can see that this is a family of a straight line which passes through the intersection of these two lines. We already know that if we are having two lines L1 and L2, then family of lines passing through intersection of L1 and L2 is given by L1 plus lambda times of L2 equals to 0, where lambda can be any real number. So comparing it with this, we are having L1 equals to yt minus a square and L2 equals to x plus y by t. From this, y will be equals to a by t and x is minus y by t. So x will be equals to minus a by t square. So we can see that this family will definitely always pass through this point. So the fixed point is this. Now, what we have to do is we need to find the relation between x1 a x2 y1 by 2 a y1 or minus 4 y1 by y2 x1 by x2 or x1 x2 plus y1 y2. So let's see. This is the value of our x2 and y2. So x2 is minus a by t square and y2 is a by t. Our x1 was a t square and y1 was 280. Clearly, multiplying x1 and x2 we are getting minus a square. Multiplying y1 and y2 we are getting 2a square. On dividing x1 by x2 we are getting minus t to the power 4 and y1 by y2 we are getting 2 t to the power 4 is 2t square. Now let's see what all options are correct. First, x1a, x2 are in GP. So x1 is a t square a and x2 minus a by t square. They are not in GP. Secondly, y1 by 2 a y1 are in GP. So y1 by 2, that is 80 comma a, and this option is y2, sorry. So y2 is a by t. Yes, this is a GP with a common ratio 1 by t. So this is our correct option. Then minus 4 y1 by y2 and x1 by x2. So minus 4 y1 by y2 is 2t square and x1 by x2 is minus t to the power 4. Clearly we can see that the common ratio is t square by 2 and minus t square by 2. So these are clearly in GP with the common ratio minus t square by 2. Now x1 x2 plus y1 y2. So our x1 x2 was minus a square and y1 y2 was 2a square. So on adding we will get a square. So D is also our correct option. So basically what we have done in this question is, it was given that tangent is drawn at any point x1 y1. So we were having any point x1 y1 on the parabola and we have taken its parametric form at square comma 280. From this we have drawn a tangent, we have found the equation of tangent and considered any random point on the tangent. So for that random point you can take x equals to h and then find the value of y in the terms of h alone. So we have got this point. From this point a chord of contact was made on the circle. So the equation of chord of contact is, if we are having the equation of circle s equals to 0, then chord of contact is t equals to 0, since this is from an external point. So the equation of chord of contact we have got from t equals to 0, and that equation is x into h because x1 was h plus y into y1 because y1 is h plus at square by t equals to a square. So from this we have made a chord of contact. Now considering this as a line or a family of line which passes through the intersection of these two lines, we have solved and find the value of x and y. That value of x and y is our fixed point x2 y2, and then we have solved it. Now moving to our next question, if the focus of the parabola x square minus kx plus 3 equals to 0 is 0 comma 2, then find the values of k. Now we can write it as x square equals to ky minus 3 or x square equals to k y minus 3 upon k. Now compare it with the general equation x square equals to 4ay x square equals to 4ay. We have 4a equals to k, so a equals to k by 4. For this equation, the focus is x equals to 0 and y equals to a. Now on comparing we are having capital X square and x square. In place of 4a we are having k, and in place of capital Y we are having small y minus 3 by k. So we are having y minus 3 upon k equals to capital A, that is k by 4. So y is 3 upon k plus k by 4, and it is given that the focus is y equals to 2. So comparing these two values, we are having 3 upon k plus k by 4 equals to 2. So you are having 12 plus k square is equals to 8k. So our quadratic will be k square minus 8k plus 12 equals to 0. And on solving this, you will get k minus 6 into k minus 2 equals to 0 as the factor. So k will be 6 or k will be 2. So our options are B and D. See, we can directly compare with the general equation and find the value of locus and directrix or vertex. Here, our equation given was x square equals to k y minus 3 upon k, and our general equation is capital X square equals to, let's say, 4 into capital A into y. Now, for this equation, we are having focus at x equals to 0, y equals to a, vertex at x equals to 0, y equals to 0. You have to just relate these two and so y to a. So just relate these two and you will get capital X and small x are same, but in place of 4a we are having k, so a is k by 4, and in place of capital Y we are having y plus minus 3 by k. So substituting this value here, and we will get y minus 3 upon k equals to k upon 4, and it is given that the value of small y is equals to 2. So we have found the value of y, which is equals to 3 by k plus k by 4, and it is given that this value is equals to 2. So substituting the value 2 and solving it, we will get a quadratic in k, and on solving this quadratic we will get two roots. If in case we were asked what is the vertex, so for vertex it is x equals to 0 and y equals to 0. So that would be x equals to 0, capital Y equals to 0. Capital X is small x same, and capital Y is y minus 3 upon k equals to 0. So our vertex will be 0 comma 3 by k. Moving to our next question. Let P be a point whose coordinates differ by unity, and the point does not lie on any of the axes of reference. If the parabola y square equals to 4x plus 1 passes through P, then the coordinate of P may be. So it is given that the coordinates differ by unity. So let's say if x coordinate is alpha, then y can be alpha plus 1 or y can be alpha minus 1. Now it is also given that this parabola passes through the point P. So point P can have either coordinates alpha comma alpha plus 1, or point P can have coordinates alpha comma alpha minus 1. Substituting the coordinates in the equation or satisfying the coordinates in the equation, we will get alpha plus 1 whole square is equals to 4 alpha plus 1. We'll get alpha square plus 1 plus 2 alpha minus 4 alpha minus 1 equals to 0. So we will get alpha square minus 2 alpha equals to 0. So alpha equals to 0 and alpha equals to 2. Now, from this, we will get alpha minus 1 whole square equals to 4 alpha plus 1. So, alpha square plus 1 minus 2 alpha equals to 4 alpha plus 1. And we will get alpha square minus 6 alpha equals to 0. So, alpha into alpha minus 6 equals to 0. So, alpha can be 0 or 6. But it is given that alpha cannot be 0 because the point does not lie on the axis of any reference line. So alpha is not equals to 0. So alpha can be 2 or alpha can be 6. But we need to find the ordinate. So ordinate will be, if this is 2, it will be 3. And When alpha is 6, then it will be 5. So our options are A and C. Moving to the next question, we are given y equals to 2 is the directrix and 0 comma 1 is the vertex of the parabola x square plus lambda y plus mu equals to 0. Then we have to find the value of lambda and mu. So rewriting this equation as x square equals to minus lambda y minus mu. So x square will be equals to minus lambda, we are taking common, y plus mu upon lambda. Now comparing it with the general equation x square equals to 4ay, we are having 4a equals to minus lambda, so a is minus lambda by 4. X is same as small x, but capital Y is equals to small y plus mu upon lambda. Now we are given 2 is the direct y equals to 2 is the directrix and 0 comma 1 is the vertex. So for vertex we are having capital X equals to 0 and capital Y equals to 0 for the general equation. So capital X is small x, so it is equals to 0, and capital Y we are having y plus mu by lambda equals to 0. It is given that, so from this y equals to 0 and y equals to minus mu by lambda. But it is given that vertex is 0 comma 1. So we can say y equals to 1, that is minus mu upon lambda is equals to 1. So that is our equation 1. Secondly, for directrix, so directrix is y equals to minus a. So y is y plus mu upon lambda is equals to minus a, that is lambda by 4. So y will be equals to lambda by 4 minus mu by lambda, and it is given that it is equals to 2. And minus mu by lambda is 1, so lambda by 4 plus 1 is equals to 2, so lambda will be equals to 4. So we are having lambda equals to 4. From this equation 1, minus mu upon 4 equals to 1, so we will be having mu equals to minus 4. So our options are A, and this is misprinted, so it is D. Now, moving to our next question. Our next question is, a quadrilateral is inscribed in a parabola, then a quadrilateral may be cyclic, diagonals of the quadrilateral may be equal, all possible pairs of adjacent sides may be perpendicular, and none of this. So, if we will draw any parabola, for the first scenario, a quadrilateral may be cyclic. Yes, it is a possible case. So, option A is correct. Diagonals of the quadrilateral may be equal. If it is an isosceles trapezium, then it can be equal. B is also a correct case. All possible pairs of adjacent sides may be perpendicular. That means quadrilateral is a rectangle. But drawing a rectangle in a parabola is not feasible and not possible. So this is not the case. How can you draw a parabola, a rectangle? Because at least you need the sides same, or you need them to be perpendicular to each other. But the parabola does not have that shape that you can draw perpendicular quadrilateral in it. So C is not the option. Our answers are A and B. Okay. So this is a general type of question. Moving to the next question. The locus of the midpoint of the focal distance of a variable point moving on the parabola is a parabola. We are given that the locus of the midpoint of focal distance of any variable point on this parabola is also a parabola. So let's say we are having y square equals to 4x in parametric form. Let's say the points 80 square comma 280. Now we are also given the points of focal distance. The point of focal distance means if we are having this parabola and this is our point and this is our focus, so the midpoint, let's say M. For focus the coordinates are a comma 0, so the coordinates of M will be its x coordinate. Let's represent it by h. It will be a plus, oh sorry, 280, a plus 80 square by 2, and y coordinate, let's say k, it will be 280 plus 0 by 2. So h we are having a plus 80 square by 2 and k we are having 80. We are given that h and k. So we have to find the locus of the midpoint, that is we have to find the locus of h and k. So how we find the locus? We have to eliminate this arbitrary variable t. So t is k by a. Substituting that value here, we will get h 2h equals to a plus a into k square by a square. So we will have 2h minus a equals to k square by a, or we can say k square equals to a into 2h minus a. Take 2 also common, so k square will be 2a h minus a by 2. Now generalizing this condition by replacing h by x and k by y, we will have y square equals to 2a x minus a by 2. So this is locus of midpoint of focal distance, which is also a equation of parabola. And the equation we are getting here is y square equals to 2a x minus a by 2. Y square equals to 2a x minus a by 2. The general equation we have is y square equals to 4ax. On comparing, we will get 4a equals to 2a, that is a equals to small a by 2. Capital Y is same as a small y, but capital X is x minus a by 2. Now let's see our options. The first option, the lattice rectum is half the lattice rectum of original parabola. So we know that the length of lattice rectum is 4a. For a general equation, y square equals to 4ax. So original parabola, it is 4a, and sorry. For the original parabola, it is 4a, and for the new locus, we can see that it is 2a. So lattice rectum is half the lattice rectum of original parabola. Length of lattice rectum is everything that is in front of y square equals to, compare it with 4a x, then you will get 4a equals to 2a. So 4a here is 2a, that is length of lattice rectum is 2a. In this case, y square equals to 4ax, this 4a is the length of lattice rectum. So the parabola we are getting here has half focal length as compared to the original parabola. So option A is correct. Let's go to option B, vertex. So we are having parabola equals to this. So equation of vertex is x equals to 0, y equals to 0, that is x minus a by 2 equals to 0 and y equals to 0. Substituting capital X equals to x minus a by 2 and capital Y is same as y. So x हमारे पास आएगा, x will be a by 2 and y will be 0. So the point will be a by 2 comma 0. Now going to talk about directrix. The equation of directrix is, for this parabola, the equation of directrix is x equals to minus a. So x is x minus a by 2 and minus capital A is also a by 2. So we will get x equals to 0. X equals to 0 is equation of y-axis. So third option is correct. Now moving to the fourth option, focus. For focus, we have x equals to a. So x minus a by 2 equals to a by 2. So you will be having x equals to a by 2 plus a by 2, that is a. So our focus has coordinates a comma 0. Moving to the next question. Let PQ be the chord of the parabola y square equals to 4ax. A circle drawn with PQ as a diameter passes through the vertex V of the parabola. If area of triangle PVQ equals to 20 unit square, then the coordinates of point P are. So we are having a parabola, we are having a chord PQ, and we are drawing a circle with PQ as a diameter and it passes through the vertex V. Okay, not a good circle, but for that. So if this is our circle and this was our parabola. So now what we are given is it passes through vertex V. So PQ is diameter, vertex V. So angle in a semicircle is 90 degrees. So this angle is 90 degree. Okay, so area of triangle PVQ will be equals to half base into height. We can say it will be multiple of PV into VQ. So we are given half PV into VQ is equals to 20. So PV multiplied by VQ is equals to 40. Now we have to find the coordinates of P. Let's say the coordinates of P are 80 square comma 280. Now we have to find the coordinates of point Q. We can see PQ is perpendicular to VQ. So slope of PQ will be y2 minus y1 upon x2 minus x1. So we will get it equals to 2 by t. So slope of VQ will be equals to minus t by 2 from the concept m1 m2 equals to minus 1 for the lines having perpendicular, for the lines which are perpendicular. Now we can find the equation of line VQ. So that will be y minus y1 equals to slope into x minus x1. So y will be equals to minus 2 by t by 2 into x. Now this point also satisfies the parabola y square equals to 4ax. So substituting the value of x, x will be equals to minus 2 by t into y. So we will be having y square equals to 4a into minus 2 by t into y. So y and y will get cancelled out and we'll get value of y equals to minus 8a by t. Now putting this value of y, we will get x equals to 16a by t square. So we are having point minus 8a by t and 16a by t square. So from the distance formula, we can find the length of PQ and we will find the length of VQ. In this one additional information, you can add A equals to 1. So we can say the point P is having coordinates t square comma 2t and point Q are having coordinates minus 8 by t comma 16 by t square. And Q was having coordinates 16 by t square comma minus 8 by t. Oh, I wrote it wrong somewhere, I guess so. X coordinate was 16a by t square and y coordinate was our minus 8a by t. Okay, now this is v. So we can find the value of PV. So value of PV from distance formula and value of VQ from distance formula, and on solving you will get this quadratic equation, and this quadratic equation is t square minus 16 into t square minus 1 equals to 0. So t will be equals to plus minus 4 or t will be equals to plus minus 1. So when we will take t equals to plus minus 1, we are having 1 comma 2, and when we will having t equals to 4, then we'll be having 4 square, that is 16 comma 8, and minus 4 will give us minus 4 will give us this point. So our options are A and B, 16 comma 8 and 16 comma minus 8. Putting 4 and on putting t equals to minus 4. Moving to the next question. Find the equation of the line that touches the curve y equals to x mod x and x square plus y minus 2 whole square equals to 4. So for the curve y equals to x mod x, we will be having two definitions depending upon x greater than equal to 0 or x less than 0. For x greater than equals to 0, we have mod x equals to x, so this will be x square. And for x less than equal 0, we will be having minus x square, because for that mod x is minus x. The other curve is a circle x square plus y minus 2 whole square equals to 4, whose center is 0 comma 2 and radius is 4. We can clearly see these two curves are passing through origin when x is greater than 0. So it is the curve, and for x less than 0, this is the curve. And this is the equation of circle having center on 0 comma 2. Okay, that's a bad circle. So we are having this circle. Clearly this line x-axis is a line which touches both of these curves at origin. So y equals to 0 is surely one of our options. Now let's move for the other options. If we say y equals to mx plus c is equation of tangent, or what we can do is we can first take for x greater than equals to 0 y equals to x square, comparing it for a equals to 1, so a equals to 1 by 4. So our equation of tangent will be y equals to mx plus a by m, that will be 1 upon 4m. Substitute this value of y in the equation to find a quadratic in m, a quadratic in x. So you will be getting x square plus mx plus 1 upon 4m minus 2 whole square equals to 4. On solving this, you will get a quadratic in x, and that quadratic in x, on putting discriminant equals to 0, you can find the value of m. This is one method. Other method is you can take the general equation of line y equals to mx plus c. First, make it tangent for this, and secondly, consider the conditions for this line to be tangent to the circle. And then from these two conditions, we will find the value of m and c. See here, we are having the line y equals to mx plus c. We say if this line touches the curve, so for the value mx plus c, we are substituting the value of y here, equals to x square, that is x square minus mx minus c equals to 0 will be our quadratic equation. From this quadratic equation, we will be having discriminant equal to 0 since it is touching the curve. So we will having the value of x as the two values will be real and equal. So b square minus 4ac will be equals to 0. So we will be having m square plus 4c equals to 0. Now the line y equals to mx plus c also touches the circle. So we can see if a line touches a circle, we are having the coordinates of center as 0 comma 2, and the perpendicular distance is also 2, and the line is mx minus y plus c equals to 0. So using the perpendicular distance formula, 2 will be equals to mod of minus 2 plus c upon under the root of coefficient of x square plus coefficient of y square. So we will have 2 under the root m square plus 1 equals to mod c minus 2. Squaring both the sides, we will have 4 m square plus 1 is equals to c square plus 4 minus 4c. Now putting m square equals to minus 4 in here, we will get a quadratic in c, and that value of quadratic will be, see it's simple, it will be 4m square plus 4 equals to c square plus 4 minus 4c. 4 and 4 will be cancelled out. M square is minus 4c, so that will be minus 16m square. Oh, sorry. M square is minus 4c, that will be minus 16c equals to c square minus 4c. So c square plus 12c equals to 0. From this we will get either c equals to 0 or c equals to minus 12. For c equals to 0, m is equals to 0, that is our x-axis. And for c equals to minus 12, we are having m equals to root 48. So the equation of tangent from y equals to mx plus c, we will get y equals to root 48x minus 12, which is our option. Y equals to root 48. 48 we can write it as 12 into 4, so it will be 2, 4, 2 coming out, then 2 are coming out, 4 root 3 it will be. So it will be our option B. Now, for y equals to minus x square, similar method we are doing. We are having y equals to mx plus c, and substituting this value, we are getting again m square equals to 4c. And substituting this in the equation, we have got from here for the circle, and we will get c equals to 20. For c equals to 20, we are having m equals to 80. So our option is option A, y equals to root 80x plus 20. That will be y equals to 4 root 5 plus 20. So from this question, we can see that we are having three options here. So basically what we have learned today was, our first point was, if we need to find the equation of tangent, then always remember, make a quadratic, or for equation or condition for tangency, make a quadratic in x or y and put discriminant equals to 0. Okay, so this was our class for parabola. Thank you everyone.